Hello, boys and girls. Today we're going to talk about expressions. When we talk about expressions, we're talking about the difference between an expression and an equation. An expression can be looked at as 5 plus 7 minus 3. An equation has an equal sign. So an equation would say 5 plus 7 minus 3 is equal to, that's 12 minus 3 is 9. So because this has an equal sign, this is going to be an equation. When we talk about expressions, there's a lot of very important vocabulary that we need to know. So our first vocabulary term is called algebraic expression. This is a mathematical phrase involving at least one variable and sometimes numbers and operation symbols. Remember, a variable, which is down here defined at the bottom, is a letter or symbol that is used to represent a number or quantities that might vary. The reason that we call it an algebraic expression versus just a mathematical expression is because it has a variable. So when we work with variables, we are working with expressions that have letters that represent numbers. So our example of an algebraic expression could be 4 plus 5 minus 2 times b. So I know this is going to be an algebraic expression because I've got my variable right here located at b, and I've got numbers as well as operation symbols. Therefore, that checks all the boxes to be an algebraic expression. Using the same algebraic expression, let's learn what a coefficient is. A coefficient is a number that is multiplied by a variable. Well, we don't see a multiplication sign here. All I see is addition and subtraction. However, anytime a variable, which we have located here at b, is directly next to a number, there is actually an invisible multiplication sign in between them. The reason why is because this does not represent place values. This 2 does not represent a number in the tens place, while this b represents something in the ones place. That is not accurate. Instead, what it represents is I have 2, a number that I know, and I'm multiplying it by a number I do not know. This b represents a number, I just don't know what it is yet. So the coefficient in our example algebraic expression is 2. 2 is the coefficient of the variable b. It's the number that's being multiplied by the variable. A constant, on the other hand, is a quantity that does not change its value. In other words, it is not attached to a variable. Not attached to a variable. So in this algebraic expression, 4 plus 5 minus 2b, I actually have 2 constants, my 4 and my 5, because those are not attached to a variable. I'm going to skip order of operations. We will come back to those since that should be a review. But let's go down here to what a term is. A term is a number or variable or a product of number or variables. So in this example algebraic expression that I have here, 4 plus 5 minus 2b, I have 1 term, 2 terms, 3 terms. So a term is either going to be a constant or a coefficient attached to a variable. These different pieces right here, 4 plus 5, is a part of the algebraic expression. It's an expression in an expression, but it's not considered to be a term. So in this particular problem, I would have 3 terms. The last thing I want to define, which should be a review for you, is order of operations. Those are those rules that we follow when simplifying, or another word for simplifying is solving an expression. So we remember the order of operations through the mnemonic device PEMDAS, PEMDAS. First, we do whatever parentheses we have in the problem, then anything with exponents. Then multiplication and division is a joint step that we do going left to right, followed by adding and subtracting, which we do going left to right. So you could subtract before you add, and you could divide before you multiply, depending on how your expression or equation is written. It's very important that we know what these vocabulary words are, so when we're working with algebraic expressions and we're explaining and working through it, you know what I'm talking about as I'm talking about the expression. Now that we know these different vocabulary words for algebraic expressions, we can talk about a few different properties. So you've heard me use that word property several times in class, especially when we were in our ratios unit and we were talking about finding equivalent ratios using the cross-multiplying property of equivalent fractions. So a property is just a mathematical concept that we know is true every time. That's a great thing about math, is that if there are any exceptions, it is few and far between. For the most part, there is absolutely no exceptions when it comes to math. So we're going to talk about several different properties. These properties that we're going to talk about are for addition and multiplication. Addition and multiplication. These do not apply to division and subtraction, because in a division and a subtraction problem, it really matters the order that you do your math in. However, as we can see here, that's not always true with addition and multiplication. The first property we're going to talk about is called the commutative property. Commutative, CO, equals change order, CO. The order doesn't matter. You will get the same answer. That's a beautiful thing about addition and multiplication. So 4 plus 5, which equals 9, is equal to 5 plus 4, which still equals 9. Just like 7 times 6 equals 42. 6 times 7 equals 42, and 7 times 6 equals 42. So again, commutative property, CO, equals changing the order. Very similarly, although a different property, is called the associative property. When we talk about the associative property, I want you to think about what the word associative means. You can see that root word associate here in associative property. Associate with somebody means to be thought of as with them. So in this particular property, the grouping changes. The parentheses will move, but you're still going to get that same answer because of the commutative property, knowing that order does not matter for addition or multiplication. So in this first example, I have 4 plus 6 in parentheses, which I know equals 10, plus 5, which equals 15. You're going to get the same thing if you were to change the order and change where the parentheses are. Change what's associated with what and what goes first. Because 6 plus 5 equals 11 plus 4 equals 15. Therefore, changing the order by changing around which operation for addition is grouped together is going to get you to that same answer. And that's the same thing with multiplication. Here I've got 4 times 2 associated together or grouped together, which I know equals 8. 8 times 3, 3, 6, 9, 12, 15, 18, 21, 24. That's still going to be equal to 2 times 3, which is 6, times 4, which equals 24. So the associative property is very similar to the commutative property, but we are changing our parentheses. Associative means what is associated with what and what comes first in our problem. Next, let's talk about the identity properties. Think about your identity. Identity is something that you are. So what this is going to mean is that when we add, for example, in this additive identity property, we want to get the same answer. So our property for the additive, which means addition, identity property is anytime we add 0, you're going to get back to the original number because I started with 5 apples, I added 0 apples, I still have 5 apples left. That's different when we multiply. When we multiply and we're using the identity property, we're actually going to multiply it by 1 because having one group of 7 apples means I'm still going to have 7 apples. So the identity property means that your identity stays the same or equal to. You're not going to change your number even though technically we are adding and multiplying. If you add by 0 or multiply by 1, you're going to end up with that same answer that you started with. Now let's talk about inverse property. Inverse means opposite. In the case of the multiplicative inverse, my answer is going to eventually equal 1. I am multiplying by its flipped version. So the flipped version of 2 is 1 over 2. I know that 2 over 1 times 1 over 2. I can multiply across to get 2 over 2, which simplifies to 1 whole. So the multiplicative inverse means it's multiplied by its reciprocal, and it's going to equal 1. My additive inverse means I'm any number plus its opposite is actually going to equal 0. When we talk about the opposite of a positive number, we're getting into integers, which we actually are not going to talk about until Unit 7. But I do want just to review with you, an integer is just the opposite or the negative form of a number. So negative 5 plus 5 equals 0. Another way of thinking of it is having 5 apples, subtracting all of them to get 0. That's the same thing as the additive inverse, as long as your answer is equaling 0 when you are either adding or, technically in this case, subtracting. The subtracting sign can also be thought of as adding a negative 5. Lastly, we have a special multiplicative property. The multiplicative property is 0. This is a property that you've probably been learning since the 3rd grade. And what it says is that any number multiplied by 0 equals 0. If I have 0 groups of 23, I have 0 items. It's very important to remember these properties because they can help you to manipulate the problems in order to simplify or solve to get a final answer. So we're going to be going through and reviewing these properties throughout this unit as we learn what an algebraic expression is, how to identify it, and how to manipulate and simplify it.